Okay, so I'm going to go over the rest of the review problems. In fact, I'm going to go over all the review problems. And in this video, you'll also see two pictures of my dog. One picture of my dog normally, and then another picture of my dog in her Halloween costume. And those will happen at different points, so you can listen to the review or you can fast forward, up to you. So, all right. So for these kinds of problems, what we're dealing with is we're dealing ultimately with distance equals rate times time. That is our formula. Another way to look at that is rate times time equals distance. And so that's, in fact, how we're going to set up this problem. And what you should know is if you've got essentially, when they say that an airplane, so I'm going to draw a little airplane here. The airplane is flying into a headwind. That means the wind speed is traveling in this direction, and the airplane is flying in this direction against the wind. And so, in fact, if the airplane's speed is some number, the actual speed of the airplane is going to be speed minus the wind. All right, so if the wind is, say, 50 knots and the airplane speed is 100, well, it's going to be more than that. It'll be like 600 knots or something. The actual speed of the airplane is going to be 600 minus 50, or 550. Okay, now similarly, if the, let me go ahead and erase this, however that works. Erase. Okay. If the wind speed is this direction and it's 50 knots, that's a tailwind. And that means you're flying with the wind, in other words. In other words, the wind is at your back. You add the speed of the wind. So in fact, this is going to be 600 plus 50 knots. And so for an effective speed of 650 knots. Okay? So the speed, if you're going with the wind, it's speed plus wind. If you're going against the wind, it's speed minus the wind. All right? So with that in mind, and keeping our rate times time, let's figure out what our variables are. So we're going to say let P equal, we're looking for the speed of the plane, so that's the speed of plane. And we're going to say let W equal speed of wind. And I think what they're doing here is miles per hour, I think is probably what they're using. So the way that you would set this up is if we said, okay, rate times time equals distance, and we create our table, essentially what we're dealing with is we're saying, okay, we travel for 3 hours into a steady headwind. So the plane, let's see, the plane flew for 3 hours, so under time it's going to be 3. And the distance was 1650, all right? Now, the rate, do we know what the rate is? Essentially, what we're doing is we're traveling for 3 hours into a steady headwind. So that means the wind is going against the plane. So we're looking for, if P is the speed of the plane, the rate is essentially P minus W, right? So it's the speed of the plane minus the wind speed. Now we can do the second one. We can say, okay, let's say it travels for 2 hours, and we know that flying with the same wind for 2 hours, they can make a trip of 1,300, so that fills in there. And so when you're flying with the wind, your speed is actually P plus W. Now wind could be current, it could be a boat in a river, traveling with the current or against the current, same thing. If you're traveling with it, you add the speed of whatever the fluid is that you're traveling through. If you're going against the current, you're subtracting the speed of that. All right, and so now what we essentially need to figure out is we have a system of two equations. This is the first equation, and this is the second equation. And the way that you would write that out is you would say, essentially, 3 times P minus W equals 1650, because we're saying rate times time equals distance. So 2 times P plus W equals 1,300. All right, those are our two formulas. Now, to distribute the coefficient, we'll just say 3P plus, nope, sorry, not plus, 3P minus 3W equals 1650. 2P plus 2W equals 1,300. And, we should feel a little bit better now that, this is looking more familiar, right? So what we can do to solve this is maybe the easiest way to solve this is just to multiply it and use elimination. So if we multiply this times -3, and we multiply this times 2, what that should give us is it should allow us to eliminate the p's. So let's figure that out. So 6p minus 6w equals 2 times 1650, which is 3,300. And then if we do the second one, -3 times 2p is going to give us -6p, so our p's will cancel out. -6w equals -3,900. I usually write the panic. All right, I usually write this on both sides just to remind me, this is negative. Okay. So the p's cancel out. We have -12w equals, this is going to be -600. Therefore, w equals -600 divided by -12, which essentially is 50. So we now know that the wind speed is 50 miles per hour. So what we can do is we can then use one of these equations, doesn't matter which one, let's say 3p minus 3 times what we now know is 50 equals 1650. So I just took this equation, 3p minus 3w, I substituted a 50 for the w, and we end up with 3p minus 150 equals 1650. We can add 150 to both sides, and we end up with 1,800. 3p equals 1,800. Therefore, p equals 600. So the answer to this is the speed of the plane is 600 miles per hour, and the wind speed is 50 miles per hour. Okay, so that solves that equation. Okay, we're going to do problem 1, and I'm going to try to explain it in a little different way from how I did it in class, and I set up the chart a little bit differently as well, but the variables are the same. So x is the speed of the train, y is the speed of the truck. That's what we're looking for. We're looking for the speed or the rate, essentially. Speed, rate, same thing. We usually express speed as miles per hour. That's a rate. That's how many miles you would go in an hour in some amount of time. So the rate for the train we're going to call x, and the rate for the truck we're going to call y. All right? Now the key to this problem is understanding that they're saying it's in the same time. Find the speed of the vehicle in the same time that a train travels this distance and a truck travels a smaller distance in the same amount of time. So you're looking for the rate. So there is no third, usually there's like a third row at the bottom, something like that. There isn't that third row this time, because what we're doing is we're really saying what is the missing variable for these two equations where time is essentially the same. All right, so the amount of time, so a train traveling at this rate goes this distance in the same amount of time as a truck traveling at this rate travels that distance, the same amount of time. So time is going to be the same. So these two values essentially equal each other. That's the sort of the thing, the insight that you kind of have to have about this. Now, this is some of the information that we have. We don't have all the information, but what we can do is we can say that if the distance is 600, and we know that rate times time equals distance, right? Distance equals rate times time. If we're looking for time, essentially time is distance divided by rate. Okay? So distance essentially here, if we go 600 over x, that's how we would express the time. Now we would say 520 over y represents the amount of time that it takes if you're traveling at y rate to go 520. All right? So essentially what we get when we equate these two is we end up with 600 over x equals 520 over y. Okay? Now, if you wanted to turn this into an equation that looks more like the type of equation that you're used to, what you'd have to realize is if we need to multiply both of these fractions by a set of common factors. So essentially, we would multiply this by xy, and we multiply this by xy. And watch what happens when we do that. We get 600 xy over x equals 520 xy over y. The y's cancel out, the x's cancel out, and you're left with 600y equals 520x. Now that's still not standard form. I mean, we're not dealing with lines, but let me just do something else here. If we say 520, if we subtract 520x from both sides, look at this. We have 600. Well, yeah, so what, we can just do this. 600y minus 520x equals 0. I really kind of got scrunched there. Equals 0. We also know that the speed of the train is 8 miles faster than the trucks. So the second equation essentially is this. X equals the truck, which is y plus 8. There's your two equations. 600y minus 520x equals 0, and x equals y plus 8. And at this point, what you could do is you could start solving it, and you could say, okay, 600 times x, nope, not x. Where's my undo? 600 times, oh, actually, wait, no, that is correct. Sorry, 600y. That's the problem with choosing x and y. They kind of look similar. Minus 520 times y plus 8. So you see what I did? I basically, if we know that x is y plus 8, I just substituted that in for the x. And we know that that equals 0. So 600y minus 520y minus 8 times 520. Some of you with a calculator will be faster than me. 4160 equals 0. So essentially this comes out to 80y equals 4,160, or y, as we figured out, is 52. We know from this thing here, x equals y plus 8, so 52 plus 8, we know that x is going to be 60. So our answer, essentially, for this is the speed of the train is 60 miles per hour. And the speed of the truck is 52 miles per hour, okay? That's what you would write. So we got our variables. We have our two sets of equations. You don't need to go to this level necessarily to have two equations, unless they're telling you, oh, you need a system of equations. In this case, we're basically just saying find the speed of each vehicle. But this is where you get those two equations. I mean, if you're asked to provide the two would be essentially 600 over x equals 520 over y, and then you would have to, I guess you'd have to change it to 600y equals 520x. I don't know. I don't think you're going to have to do that, but if you should at least know that, this is kind of like that problem that you saw one time on one of the tests that, this is essentially, you're multiplying it by xy in order to cancel out one of those variables. And believe it or not, you guys have been doing this all, ever since you've been doing algebra. You just haven't been doing it with variables. But if you have questions, bring it up in class. I can talk to you more about it. If you had to solve this just on its own, the easiest way is probably to say, okay, if we know that x equals y plus 8, then you can say 600 over y plus 8 equals 520 over y, and then cross multiply. So 520 times y plus 8 equals 600y. And you can solve this, you can solve for y that way and then plug y back in and then get x. So I mean, that's a faster way to solve this. But I know that we've been emphasizing going over, the steps and finding the system of equations, but I wanted to go over in more detail how you would derive two equations from it. This is a distance equals rate times time problem, but it is different from this one with the plane. And you could see either one, right? But just read carefully and try to understand, is there a constant, in this case the same time, or is it something like they're traveling against a current? And in that case, you can just get your two equations that way. Just keep doing more problems and you'll probably run into examples of both of these. Okay, so finally, picture of the dog is right there. And yep, more good than best. That's my second, what happened? Okay, here we go with the third problem. Now this is the other kind of problem that you're going to be asked to solve. Besides distance, rate, time, you have money. And the idea behind investment is you take a certain amount of money and you put it in a bank, and the bank will pay you a percentage of that money every year just for the privilege of holding on to your money. So if you put in, say, $1,000 and that $1,000 earns 5% interest, then at the end of that year, you should have 5% times 1,000. You should have, $50 in interest that your money is going to make. That's the idea behind investment. So when you look at a problem like this, the basic formula, is essentially the amount that you invest times the interest rate, which is going to be a percentage, and then you can express it as a decimal. And that equals your return on your investment. Now you'll notice when you look at this is very similar to a mixture problem. And so essentially for something like this, if we say $15,000 is invested, how much was invested at each rate? We have two separate funds. One pays 5% and the other pays 7%. So what we're going to say is we're going to say let X equal the amount invested in 5% fund, or at 5%. And we're going to say let Y equal the 7% fund, the amount in dollars invested in that 7% fund. Okay? So X is the amount invested in the 5% fund. Y is the amount invested in the 7% fund. Now, how do you set this up? Well, we're looking for X and Y. So we're looking for the amount invested. We don't know how much we're investing in the 5% fund. We don't know how much we're investing in the 7% fund. But what we do know is that between these two, we know that the total is 15,000. So this is 15,000. Now, the interest rate we can fill in. This is 5%, so that's 0.05. This is 7%, so that's 0.07. And the return is essentially going to be 0.05x plus 0.07y. And we know that the annual return from the investments, in other words, the amount of money that you get from investing some amount at 5% plus some amount at 7%, the amount of money total that you're going to, well, the amount of money that you're going to get is essentially 950. The annual return from those investments is 950. So we've defined our variables, and now we just have to set up our system of equations. And the way that we do that is we take these two, this right here, that amount, and then we take this amount here. That's our second equation. So what this looks like, the first equation looks like x plus y equals 15,000, right? The total amount invested is 15,000. 0.05x plus 0.07y equals 950. That's our second one. So what we're going to do, first of all, is we're going to get rid of our decimals by multiplying both of these by 100. And what you'll end up with is 5x plus 7y equals 100 times 950, which is 95,000. And we have x plus y equals 15,000. So if we say minus y from both sides, we can say x equals 15,000 minus y. So now we can solve this using substitution. We can say 5 times x, which we know is 15,000 minus y, and we can add to it 7y, and we're going to end up with 95,000. And so 5 times 15,000 is, what's that, 75,000? And then we're going to say minus 5y plus 7y equals, and move this over, and so that is equal to 95,000. And then we can subtract 75,000 from both sides. And negative 5y plus 7y is essentially 2y equals 75, 85, it's 20,000, right? So y equals 10,000. So we know that we've invested $10,000 for y. Y is the amount invested in the 7,000 in the 7% fund. So y is 10,000. If we put in 10,000 here, if you subtract 10,000 from both sides, then x equals 5,000. So essentially, the answer is it's so much money, I'm tongue-tied. 5,000 is invested at 5% interest, and $10,000 is invested at 7% interest. Sorry, that's a messy, but that is the answer. So 5,000 and 10,000. But that's how to do one of these problems. It's pretty straightforward if you think about it. It's kind of like a mixture problem. But as long as you put it in the table like that, then you can set up your equations in that way. Okay. All right. So here, this is kind of an interesting one. This is a department stores 3 kinds of perfume: cheap, good, and best. It has 10 more bottles of cheap. So this is like three equations, because they're saying how many bottles of each are there. So all you need to do is you just say let x equal cheap perfume, let y equal good perfume, and let z equal best perfume. And then in order to just sort of figure this out, we just need to just kind of set up. So basically, you know, this is sort of like price, right? So price per times the amount equals the total price. So that's how you kind of set this up. So price times amount equals total. The prices are listed here. So each bottle of cheap costs 8, good costs 15, and best costs 32. And then we can kind of look at the amounts. Excuse me. So good, you know, the interesting thing here is the amounts of each, amount of, this is amount of, and this is amount of. The amounts of each are expressed in terms of good. So if we say, and you know what I'm going to do, let's make G good, let's make C cheap, and let's make B for best, okay? B, G, and C. So the cheap is this stuff, the G is this stuff, and the B is this stuff. And your total is going to be essentially 8C, 15G, 32B. Okay, so essentially we're saying 8C plus 15G plus 32B, all of that equals 589. But what they tell you is they essentially define what each of these things is. Because C, cheap, is defined in terms of good. 10 more bottles of cheap than good. That basically means C is actually G plus 10. There are 3 fewer bottles of best than good. So essentially B, I keep doing that. It's throwing me off. All right, B essentially is, let me erase this. B is G plus, G minus 3. So the way that you would solve this is you would essentially say 8 times C, which is G plus 10, plus 15 times G, I could have just said 15G, plus 32 times G minus 3, all equals 589. And then you can just sort of solve this out. This ends up being 8G plus 80 plus 15G plus 32G minus, what is it, 32 times 3 is 66, so that's like 66, minus 66. No, it's not 66. Where's the eraser? 32 times 3 is 96. And that equals 589. Yeah, got it. That feels better. All right, so then we're going to combine like terms. So 32 and 15 is 47 plus 8 is 56. So this is 56G plus 80 minus 96 is negative 16 equals 589. Let me just make sure that I added this correctly. So 32 plus 15 is 47. Plus 8 is 55. My bad. 55. 55G minus 16 equals 589. 55G equals 589 plus 16. And that is 605. So 55G equals 605. So therefore G equals 605 over 55, which I believe we can simplify because you can divide 5 certainly into this. And 5 into 605 goes 121 times. 5 into 55 goes 11 times. Oh, and actually 11 squared is 121. So this is 11 times 11. So basically this is just 11. 11 goes in 121 11 times. So that's 11. So G is 11. And if you know that G is 11, then this is going to be 21 and this is going to be 8. So you have 21 bottles of cheap perfume, 11 bottles of good perfume, and 8 bottles of best perfume. This is super messy. Sorry about that. Maybe I can kind of make this, there we go. Oh, that's so much better. All right, and then finally my dog. Oh my God, my dog's gone. I've lost my dog. Okay, I think if I do this, oh, there it is. Okay, so yeah, that's my dog. So that's her Halloween costume. She actually has a tactical vest on and goggles. She's like those dogs that they use with SEAL teams, right? So she's like a special forces attack dog. Although she's a golden retriever, I think she'd probably lick you, and that's probably about it. But yeah, that's her costume. It's too bad. I should have the patches. I have another picture that has patches. I'll show that to you guys. Okay. If you have any questions, as always, let me know. Thanks. Bye-bye.